Good day, friends. Right now, let's try to solve this problem on torque. A ladder 4 meters long leans against a smooth wall at an angle 60 degrees to the horizontal. So which is looks like this. Yeah, this is a ladder and 60 degrees is there. It leans on the wall. The coefficient of friction between the ladder and the floor is 0.25. The mass of the ladder can be neglected. At what distance along the ladder can a person climb before the ladder begins to slip? Okay, so it must look like this. Yeah, we have this kind of situation. We don't know where this human being will be. Yeah, we know that at a certain distance, it will slip away. Yeah, this ladder starts to slip from the floor, right? So let's try to analyze the situation. We definitely know that there is a normal force which is acting here. We also can say that there is a, well, this thing is trying to slip off this side. It tries to accelerate this side, and we definitely can say that the friction force is acting this side. Friction force is here. Also, we know that here we have a normal force, which is different. Normal force 2, let's call it normal force 1. And we can also say that this human being has a mass, right? This is mg. It is a mass of a human being. It's not a mass of the ladder because it was clearly said the mass of the ladder can be neglected. Okay, and we need to take this into account. Because of this is a problem about torque, we can definitely say that these forces are trying to rotate our ladder, but they are not. So we can definitely say that normal force 1 is trying to rotate this side. This is torque 1. Torque 2, normal force 2 is trying to rotate a ladder counterclockwise. Friction force is trying to rotate clockwise. This is, let's call it torque 3, and mg is trying to rotate this side. This is torque 4. Okay, good. So we definitely can say what? We have a sum of forces, sum of torques equals 0 because it is not being rotated. We definitely can say that this torque 1 is positive and torque 3 is positive because they are trying to rotate clockwise, and torque 4 is minus, torque 2 is minus because those two are trying to rotate our ladder counterclockwise. They are trying to oppose torque 1 and torque 3. So let me write it here. Torque 1, it is positive. Torque 3 is positive. It is trying to help torque 1. But torque 2 and torque 4 are negative because those two are trying to oppose torque 1 and torque 3. This is 0 because it is not being rotated. And I can move these two things another side and make them positive. It becomes just torque 1 plus torque 3 equals torque 2 plus torque 4. Okay, good. And right now we know this thing that torque is just force cross product R, which means that this force which is trying to rotate has to be perpendicular to the distance from the pivot. Yeah, pivot is the point due to which we're trying to rotate our object. Okay, let's choose some convenient point which will be comfortable to us to work with, and let me choose this point. Why? Because we can cancel out two forces, which are friction force and normal force. Why do we cancel them out? Because the thing is, there is no distance from the force to the pivot. Even though there might be the perpendicular components, there is no radius. Radius would be 0. That's why it does not matter. Yeah. In fact, if I just break it down, it would be just what? Let me just take some different. Yeah, maybe this pink. It would have something like this sort of, and here, this kind of components. And mg has component down and here. Normal force has a component here and here. Yeah, and if you ask me how do I do it, in fact, it's not that hard, but let me take this thing and show you one more time how I identify these components. So if I take this thing and I rotate it like this, yeah, I have here, yeah, I also have this force. This is friction force. It was here. Well, how did I identify that these forces look like this? They are components. Well, as you can see, this line, my ladder, is now horizontal, but my forces are not perpendicular to it. That's why I need to take only those components which would be perpendicular to my radius, right? That's why I just take this component and this component. This component, this one, this one, this one, oops, this one, and this one. So I can definitely say that I don't need, let me draw it with red, I don't need this component, I don't need this component, and this component. Why? Because those things are horizontal. Those components cannot rotate my object. But this is yellow, this one is yellow, this one, and this one. These components can rotate because each one of them are perpendicular to my object. Okay, good. And this is exactly the same thing that you see here. And if I say that this is angle alpha, yeah, 60 degrees, it means that this angle is also alpha. Why? Because I know that this thing is 90 minus alpha, and this thing has to be just alpha. Yeah. And this thing is also 90 minus alpha, which means that all these things have to be just opposite. Yeah, if opposite here, if it is friction force sine alpha, in general, yeah, because it is opposite, but we can see that this is 90 minus alpha. That's why it would be totally opposite. It would be just friction force cosine alpha. Okay, this would be friction force cosine. This is friction force sine alpha. And this is adjacent, that's why it's normal force N2 cosine alpha. And this is N2 sine alpha. Okay, good. And here we just can continue this line. Yeah, let me just continue this line. This is 90 degrees. This has to be 90 minus alpha, which means that this angle has to be alpha. Good. I hope it's pretty obvious, right? So I can say that this is just mg. Yeah, let me draw it with red because anywhere else I'm drawing it with red as well. So it has to be just mg sine alpha. And this is mg cosine alpha because it is adjacent cosine alpha. Okay, and what about this angle? So I know there is a law in geometry, which is law of z, I call it, yeah, and maybe it's called z, yeah. We have this kind of z in here, and if this angle is alpha, then this angle is alpha as well. So this angle has to be also alpha, and this angle has to be 90 minus alpha, which means that it has to be totally opposite. So in general, if it was just alpha, this side would be f sine alpha because it is opposite. But we have here 90 minus alpha, as you can see it. Then this thing has to be what? Normal force 1 cosine alpha, because it is in general sine 90 minus alpha, which turns to cosine alpha. Okay, this thing is just n1 sine alpha. Okay, good. So let me take this away somewhere here. And my torque 1, which is normal force 1, and the perpendicular force is n1 sine alpha. It is here. Let me just write it, n1 sine alpha. And if my pivot is this green point, yeah, this, as you can see, very intense green point is my pivot. It is the entire length of the ladder. Am I given? Yeah, I'm given with the lengths of the ladder. And this has to be just L. Yeah, this is pretty good. What about torque 3? It is here, yeah, torque 3. It is this thing, friction force sine alpha. Let me write here, friction force sine alpha. But the problem is about, it is just 0 radius from the pivot, which means that we can just multiply it by 0. Torque 2 would be what? Torque 2 is here. This is n2 cosine alpha. N2 cosine alpha. And as you can see it here, it is also 0 distance from the pivot. That's why it would be just 0. And plus here the last thing, torque 4, which is mg cosine alpha, mg sine alpha. Is just parallel to our ladder and it cannot rotate, only mg cosine alpha can. And mg cosine alpha is just half of the length away from the pivot, right? So it would be just mg cosine alpha L divided by 2. Okay, so I can take this thing away. It would be just what? N1 sine alpha L equals what? Mg cosine alpha L divided by 2. Good. And what I was meant to find, at what distance along the ladder can a person climb before the ladder begins to slip? Okay, there is a little mistake. This is not a half of the length. Why? Because this thing is not said that when the human being reaches the half of the length, this thing starts to slip. No, it is not. This is not a half of the length. It is some point, let's say some x. That's why this thing would be just x. This thing would be just x distance. Even though it is not much of a problem, it would be just n1 sine alpha L and divided by mg cosine alpha, and that's it. I can see that here I have sine alpha and cosine alpha, which are just tangent, and I can say that this is n1 tangent alpha L divided by mg. Am I given with all of the factors? Well, let's look. I have length. I have a mass of a human being, I guess. No, I guess no, I'm not. I'm given with a friction force, which is 0.25. This is a mu, the coefficient of friction, which means that in my answer, there has to be somewhere a mu. And I have also alpha, well, definitely, and L here. Okay, that's not a problem, in fact, because I know that this is in total equilibrium. That's why it means that sum of forces is also 0. And it is pretty easy, in fact, because I definitely know that horizontally, I have N1, just N1, and friction force, which are opposing each other. I can definitely say that N1 equals friction force. If you ask me why, because I can just say normal force minus friction force equals 0. It's not moving. That's why I can just say that these two things are just equal to each other. I can also say that normal force 2 is equal to mg. Because it is also in equilibrium in vertical axis. This is just normal force 2 equals mg itself. Well, I definitely know that friction force is just the mu n2, right? And I have that mu n2. I have n2 right here. I can put it here, which gives me friction force equals what? It is mu mg. It is mu mg. And my n1 equals friction force, which means that n1 equals mu mg. And yeah, good, pretty good. I can just put that mu mg in here, right? You can see it, mu mg here, tangent alpha multiplied L divided by mg as well. That's why these things just go away, and I have just my answer, which is mu tangent alpha multiplied L. Mu is 0.25. Yeah, I have it. 0.25 multiplied tangent alpha, which is just 60 degrees. Tangent 60 multiplied L, it is 4 meters. So I can definitely say that this thing, 0.25 multiplied by 4 is just 1. Yep, this thing is 1. And tangent 60, well, let me remember, if I'm not mistaken, this thing is just square root 3, I guess. Yeah, if I'm not mistaken, tangent 60 degrees is just square root 3. And it gives me just 1.73 meters, which is correct answer. Yeah, pretty good. So my answer, my original answer is just right here. My distance is just mu tangent alpha multiplied by L. It is here, 1.73. But the most important thing about this, if you look at here, there is no mass of a human being. It just cancels out right here, which means that it doesn't matter what is the mass of our human being. Only things which matter in this case are the coefficient of friction between the ladder and the ground, the angle and the length of our ladder. So this is the end of the video. I hope everything is clear to you, and if not, you can definitely write me privately. Thanks for your attention. Goodbye.